Hi, hello, namaste. This is our teaching channel. So, those who are first time watching this channel, please subscribe and click the bell icon for the more updates. Today, we are going to discuss about real number in chapter 1, 10th class. Real numbers. Before we are going to discuss about real numbers, some of the basics are so we want to know already natural number. So natural numbers are nothing but all countable numbers are called natural number. For suppose these are the started from 1, 2, 3, 4, 5 and so on infinity. These are the natural number. And then including 0 to the natural number, including 0 and all the natural numbers are known as infinity is known as whole numbers. In the same manner, the natural numbers and the whole numbers and also as well as negative number. So integers is equal to, here it is the negative numbers, negative number plus a positive number. So simply we say that this as a v1, v minus v plus as well as a negative number plus whole numbers are called integers. So whole numbers are nothing but minus dash 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 minus 3 comma minus 2 comma minus 1 comma 0 comma 1 comma 2 comma 3 comma 4 and so on infinity. Here also infinity. These are the integers. Integers are denoted by letter capital I or Z. Here we go. These are negative numbers because it indicates the minus value, and these are positive numbers. And 0 is neither negative nor positive. Neither negative nor positive. So here Z plus and Z minus means Z for also integer, it is denoted by integer. Here Z for is the name of mathematician junior and plus symbols indicates 1 comma 2 comma 3 comma 4 or 0 1 2 3 4 and negative symbol indicates minus 1 minus 2 minus 3 minus 4 as well as. Okay, suppose 1 comma 2 comma 3 comma 4 and so on, and the negative numbers minus 1 comma minus 2 comma minus 3 comma minus 4 dash dash and so on. You observe here in the number line the numbers are indicated. 0 to the right is a positive, 0 to the left is a negative. When we move on the number line in right hand side, that means forward side is positive numbers and the value will be increases. When we move left on the number line, suppose when we move right, the value will be increases. When we move left on the number line, so the value will be decreases. When we move right side, the value increases. When we move left side, the value will be decreases. Apart from this, every integer has a successor. What is successor? Successor means adding 1 to the given number. Suppose successor of 1 is 2, successor of 2 is 3, successor of 3 is 4, successor of 4 is 5, means it are infinity. And every number has a, suppose successor of minus 2 successor is minus 1. In the same way, minus 1 successor is 0. Every number is a successor. But every number is also every integer is also a predecessor. 0 integer minus 1 integer minus 2 integer, sorry, predecessor. Predecessor. So every number, predecessor means minus 1. Every integer has a predecessor. But you observe here, every natural number has a successor, but every natural number has a predecessor except 1. Except 1. 1 has no predecessor because it is started from 1, no other number before it. In the same way, every whole number has a successor and every whole number has a predecessor except 0. Except 0, every whole number has a predecessor. Predecessor means just before number. Successor means just after number. Just after. And just before. Just after number is called successor, just before number called predecessor. Okay. So this is the some small information about natural number, whole number and integer. And also a key points are here. Every natural number has a successor and a predecessor, and smallest natural number is 1. Smallest natural number is 1. Largest natural number not defined. Not defined. In the same way, every whole number has a successor and a predecessor except 0, and here smallest whole number is 0, largest whole number is not defined. Similarly, integer, every integer has a successor and a predecessor, as well as here every integer, smallest integer, we can't take direct smallest integer because it is a positive and a negative. Suppose smallest positive integer is 1, largest positive integer is not defined, and smallest negative integer not defined, because I already told you when we move left of 0, the value will be decreases. That means minus 1 is greater than minus 2. Minus 2 is greater than minus 3. So minus 1 is bigger than all the all the negative integer, and also less than all the positive integers. So what is the largest negative integer? Largest negative integer is minus 1. Smallest negative integer not defined. You observe 0 is always greater than the negative integer, and 0 is always less than the positive integer. 0 is less than the positive integer, 0 is greater than the negative integer. So minus 1 is always greater than every negative integer. For suppose I am taking here 1 lakh, minus 1 lakh. This is the minus 1 lakh. And which is greater, minus 1 lakh greater or minus 1 greater? Minus 1 is greater. Okay, because minus 1 is always greater than the every negative integer, because here it is left of 0. When we take a number line, it moves left side and this moves right side. Okay. So apart from this, every integers is also known as rational numbers, denoted by letter Q. Rational numbers. What is rational number? The important topic here. Irrational numbers means the numbers which are in the form of, suppose the numbers which are in the form of P by Q. Numbers which are in the form of P by Q, where Q not equal to 0. Q not equal to 0. And also P and Q belongs to integers. Here, the numbers which are in the form of P by Q, where Q not equal to 0, P and Q belongs to integers. This type of form is known as rational numbers. Rational numbers are denoted by letter Q. The numbers, one second definition, the numbers which are in the form of P by Q, where Q not equal to 0, P and Q belongs to integer. This type of numbers known as rational numbers. What are irrational numbers? Irrational numbers are denoted by the letter Q dash. For suppose the numbers which are not in the form of P by Q, these numbers are called irrational numbers. So by using a rational and irrational number, here we are solving some of the problems in this chapter. Suppose some examples of irrational number, root 2 and root 3, as well as, okay, like that here rational numbers, you already know, whatever you take the rational number, any integer is a rational number. Suppose 2 is a rational number because 2 by 1, because it is in the form of 2 by 1, it is in the form of nothing but P by Q. So it is called a rational number. As well as all the rational numbers and irrational numbers is known as real numbers. This is our topic. All rational and irrational numbers. The combination of rational and irrational numbers are known as real numbers. So in this chapter, we learn about rational, irrational, as well as arithmetic theorem. What is arithmetic theorem? Before we are going to inside of the chapter, arithmetic theorem is very important now. This chapter, arithmetic theorem. What is arithmetic theorem is every positive integer is greater than 1. Every positive integer is greater than 1. This can be factorized by prime factorization. So how means? That means every positive integer greater than 1, we can write product of primes. Product of primes. This is also known as unique prime factorization. Once again, every positive integer is greater than 1. We can write this as a product of prime numbers. And this is also known as unique factorization, unique prime factorization. For suppose I'm taking one of the example. Here we go. Suppose I'm taking 18. 18 is a positive number. 18 is a positive number, and also it is a greater than 1. We can state this as by using a prime numbers. Before we are going to this, so 18 is a greater than 1. 18 is also known as a composite number. And also we can use this arithmetic theorem. Every composite number can be written as a product of unique prime factorization. That means here we go. Suppose before we are going to solve this type of problems, first of all we know the prime numbers. So now you want to know the prime numbers means here first of all I introduce your prime numbers. What is prime number? Prime numbers means a number which is having the factors only 2, that 2 are nothing but 1 and itself. For suppose I am taking a number 2. 2 have the factors only 2 table and 1 table. 1 2s are 2, 2 1s are 2. So only 2 have factors 2 comma 1. See, you observe here any prime number having the factors only 2 that are nothing but one factor is 1 and other factor is itself. Itself means same. And suppose I am taking a number 3. So 3 also have a factor 3 and 1 only. This also 1 is itself and other is 1. So this type of numbers are known as prime numbers. And suppose I am taking a 4. 4 having the factors 2 2s are 4, 2 2s are 4, 1 4s are 4, 4 1s are 4. How many factors? 2, 1, 4. Total 3 factors. For 4 having 3 factors. Any number more than 2 factors is known as composite number. Okay, only 2 factors is known as a prime number. Now, how to know the prime numbers means first suppose I am giving to you code also for these prime numbers. Okay, so first of all 1 to 10, 1 to 10 to 10 to 20, 20 to 30, 30 to 40, 40 to 50, 60 to 70, 70 to 80, 80 to 90, 90 to 100. First of all, we want to know the prime numbers from 1 to 100. See, I am telling you code also. So first of all, know the prime numbers here. 2, 3, first 1 to 10 prime number. 2, 3, 5, 7. How many numbers are there? 4 numbers are there. Suppose here D. And the code you can write here like this: D, D, B, B, C, B, B, D, D, B, B, C, B, B, C, B, A. Once I am here. Wait, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, here 60 to 70. What? Sorry, here I missed here. 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Now code is possible. BBC, BA. Now English letter D is 4 and D is 4 and it is a 2, 2, 3, 2, 2, 3, 2, 1. DD, BBC, BBC, BA. By using this code to find 53, 59. Now 61, 67, 71, 73, 79, 83, 89, finally 97. So by using this code, once again DD, BBC, BBC, BA. 1 to 10, how many prime numbers are there? D means 4 prime numbers. So similarly, 10 to 20, how many prime numbers are there? 4. So 4 means D, and like that, we are following this code DD, BBC, BBC, PA. So these are the prime numbers. Must understood these are prime numbers. We want to know that, and we want to show the prime factorization of given positive number or composite number. Any of the number greater than 1, we have the factors more than 1. That numbers is known as a composite number. 1 is neither prime nor a composite number. Here we go. Suppose I am taking 18. So factorize the following numbers. You remain in the mind 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers. Keep it in your mind and also continuous of 1 to 100 prime numbers are important. 2 nines are 18. Again 2 not possible. 2 table is 9 not there. It is not an even number. Before we are going to solve, we know the divisibility rules also very important. Divisibility rules. So what are the divisibility rules? Suppose by 2. If even numbers only divisible by 2, what is by 3? Some of the digits are divisible by 3, then the number also divisible. Some of the digits are divisible by 3, the number also divisible by 3. And 4. By 4 means last 2 digits is divisible by 4, and the remaining rest of the number is also divisible by 4. Complete number is also divisible by 4. By 5. By 5 said that last digit is 0 or 5. And by 6, if 2 and 3 is divisible, 6 also divisible. So like that, some of the divisible rules also known means it is possible. But it is a not even number. Even number only divisible by 2. So it is not even number. Next we are taking sum of the digits. Only one digit is there. 9 in the 3 table is there. That's why 3 3s are. Now 3 is also a prime. 3 is also a prime. Now we are started. Prime factors of 18 is prime factors of 18 is 2 into otherwise is equal to 2 into 3 into 3. 2 3s are 6, 6 3s are 8. And like that, we want to take another number 24. 24 means the 2 table I am taking first 2. For 2 is not possible, then we take 3. 3 is not possible, we can't take 4. 4 can't take because 4 is a composite number. Only we need to take prime number to factorize this. 2 1s are 2 2s are 12 is there. 12 is the 2 table? Yes sir. 2 6 are 12. Again 2 3s are. Now prime factors of 24 is equal to 2 into 2 into 2 into 3. So these are the finding prime factorization by using prime numbers. Here the introduced HCF and LCM. Suppose prime factors of for these two numbers, what is the HCF of 18 and 24? HCF of 18 and 24 is means first of all we want to take the common factors of both. These are 2 into 3 into 3. These are 2 into 2 into 3. In this, what is the common factor means 2 into 3 only common factor. 2 into 3, both of these. This common factor is known as HCF. 2 3s are 6. HCF of 18 and 24 is 6. And the same question giving LCM. LCM of 18 comma 24 is equal to LCM means in the common factor 2 into 3, 2 into 3 is there. Only one we are taking. 2 3s are 6. Common factor, I mean HCF into remaining factors. Remaining factors what are there? Here 3 is there and here 2 into 2 is there. Then multiplication, here we go. 6 3s are 18, 18 2s are 36, 36 into 2, 2 6 are 12, 2 3s are 6 and 7. 72 is LCM. Once again look at here. So first we are finding the prime factorization of 18. 18 is 2 into 3 into 3 and the prime factorization of 24. Here we are finding 2 into 2 into 3 2s into 3. After that, what are the common factors? 2 into 3, 2 into 3 only. These are the extra factors. The 2 into 3 is a common factor. The 2 into 3 is nothing but the HCF. And also we are taking the remaining all the numbers, all the rest of the numbers under the HCF value. HCF is 6 and the remaining numbers are 3, 2, 2. So multiplication to get a 72. This is the LCM. Relation between LCM and HCF. Relation between LCM and HCF is nothing but LCM into HCF is equal to product of two numbers. Product of two numbers. Or here 3 formulas are writing here by using this one. The relation of HCF and LCM. LCM is equal to product of two numbers. Suppose product of two numbers are taking A into B by HCF. Similarly, HCF is equal to product of two numbers by LCM. If one number is given, we need to find other number. So here, suppose A into B is equal to HCF into LCM. Suppose B, we want to find B value. I mean product of one number value. We want to know the one number value, HCF into LCM by A. Suppose we need A is equal to HCF into LCM by B. So these are the finding the values of these numbers. Suppose we are solving here. I am solving here HCF and LCM, and both are product of two numbers which is equal or not. Let us check out. LCM of 18 and 24 is 72. HCF of 18 and 24 is 6 is equal to product of two numbers. What are the two numbers? First time solved 18 and 24. Now multiplication, product means multiplication. 6 2s are 12, 6 7s are 42, 42 1 43, 432. Similarly 18 4s are 72, 18 2s are 36, 36 or 7, 36 to 7 is 43. Both are equal. So this is the relation of HCF and LCM is equal to product of two numbers. By using this formula, we are solving many problems in this real number. So for understand purpose, I'm telling only basics of this. Then we go to next exercise basics in the next video.